Hello and welcome to this session. So in today's session we are going to be discussing network address translation. We are going to understand what is network address translation, and we are going to also understand what role network address translation plays in our networks. Now, what is a network address translation? Now basically network address translation helps us translate private IP version 4 addresses into public IP version 4 addresses. Okay, and where did this private and public IP version 4 addresses come from? Now, as the number of internet users increases or increase, public IP version 4 addresses became scarce, and as we all know, the number of available addresses in a network is determined by the formula 2 raised to the power of available networking bits minus 2, okay, which are basically the network address and the broadcast address. Okay, now the available host address space on the internet is therefore 2 raised to the power of 32 minus 2, which gives us approximately 4.3 billion IP version 4 addresses. Now, as we all know, the number of devices that are now globally have surpassed this number, which means that now we cannot use IP version 4 addresses to directly go to the internet. These addresses have to be shared. Okay, so that is where basically the concept of private and a public IP version 4 addresses came in. Now, due to uneven allocation of these addresses, there was shortage of available IP version 4 addresses in some areas. Now, some organizations have these public IP version 4 addresses, which means they can directly connect to the internet, but others don't. Now, to overcome this problem, private and public IP version 4 addresses were introduced. Now, public IP version 4 addresses are managed and allocated by a dedicated authority or a organization, in this case IANA, which stands for Internet Assigned Number Authority, and can be used for direct communication on the internet, while private IP version 4 addresses can be used by organizations or individuals randomly on internal networks, but cannot be used for direct communication on the internet. I believe the difference has clearly come out. It means that in order to solve this problem, we had to divide the IP, the 4.3 billion IP version 4 addresses into a public and a private IP addresses. Public IP addresses can directly communicate with the internet, while private IP version 4 addresses have to be translated first in order for them to communicate to the internet, and they are translated into public IP version 4 addresses. Now, the private IP version 4 address space is divided into 3 classes, and class A, private IP version 4 addresses. In the first octet, we usually have the value 10 with an 8-bit network header and a subnet mask of 255.0.0.0. Class B, in the first octet, will have the value 172, and it is a 16-bit network header and comes with a subnet mask of 255.224.0.0. Now, the 224 comes in because the range of class B addresses go from 172.16.0.0 to 172.31.255.255. that is the range of class B private IP version 4 classes. Now, class C private IP version 4 addresses in the first octet come with the value 192 and have a 16-bit network header and come with a subnet mask of 255.255.0.0. So this is the basic private IP version 4 addressing class. Okay, now let us talk about public IP version 4 address classes, since we have talked about private ones. In public IP version 4 address classes, the first octet comes with the value 0 to 127 with an 8-bit network header and a subnet mask of 255.0.0.0. Class B comes in the first octet with the value 128 to 191 with a 16-bit network header and a subnet mask of 255.255.0.0, while class C in the first octet come with the value 192 to 233 with a 24 network bit header and a subnet mask of NAT translate IP addresses into IP data packets on live networks and is usually deployed on network egress devices such as routers or firewalls, which means that if you're setting this type of service to translate public IP version 4 addresses into private IP version 4 addresses, you're basically going to do it on your egress device. This is the device that reaches out to the other networks outside your network. Okay, and you basically set up the inside global, outside global, inside local and outside local addresses in order for this network address translation to happen. Now, there are basic types of NAT that we need to know. Static NAT, which refers to where a private IP address is mapped to a fixed public IP version 4 address, and this means one device to one device, one IP address. Okay, and this is what basically happened earlier. Organizations were being given these IP addresses that enabled them to go directly to the internet, and this led to shortages. So now there is what we call dynamic NAT, and this way you set up a pool of public IP version 4 addresses, and a private IP address is mapped to this pool of public IP version 4 addresses. Okay, and basically works that if a public IP version 4 address is in the pool and is not being used, and an internal network needs to use this IP version 4 address, so it just picks one from the pool and uses it for direct communication to the internet. And this basically helps reduce wastage of public IP version 4 addresses, where instead of assigning one address to one private IP version 4 address, you fix a pool of public IP version 4 addresses to a private IP, and whenever a public IP version 4 address is available and is in the pool, and private IP version 4 address wants to reach out into the internet, so it will just, the egress device will just assign one public IP version 4 address to this private IP version 4 address and help it communicate, and afterwards, after using it, it will be returned back to the pool. There is what we call port address translation, and in other literatures we call it network address and port translation. This translates both IP addresses and port numbers from multiple hosts into one address in an address pool. This is where basically you have multiple users using one public IP version 4 address, and they could be running multiple services on this public IP version 4 address, and basically this type of translation remembers what client had sent out this request, and when traffic is coming back to the network, it basically remembers that a user or client through port numbers and the IP address. Okay, so port numbers help keep these connections on, instead of now assigning multiple private IP multiple public IP version 4 addresses. You offer one public IP version 4 address to serve multiple users, and they will be kept track of using the port numbers or the types of services that they are accessing on the internet. So I believe that's it when it comes to network address translation. See you in the next one.